math tournaments, like in my fourth year or whatever. Anyway, things we got. And he pointed out, I hadn't thought about this very much, but I have the students present, and every time they present, I say thank you, you know, and he was like, that is so great that you say thank you every time, and I'm like, why wouldn't I? They just stood up there, and like, they did something really embarrassing, like, for them, it's like a real, like, position of risk.
I have been constantly.
I did that for a while, and then there was one student who was like really upset by the applause for some reason, and so I kind of modified it to like, thank you, let's thank so and so, you know, but just to say thank you. And this geology professor was so like amazed that I did it. Why wouldn't you think that?
And then also the teachers that memorize that negative plus negative is negative, but they can't show you on the number line, then they're not going to be able to get that negative plus negative. Yeah, because the kids will come in from 8th grade and they'll say, no, I clearly remember that my middle school teacher told me that negative plus negative is positive.
My feeling is that one of the things we ought to do first is for those of you who are relatively new at it to ask questions from those of us who've done it for a while. That I think does a better job of getting 2 points that are important to you. Realize that in asking those kinds of questions, you may get different answers from different ones of us. But that's exactly the point, that there's lots of ways to do it. So I would...
Here are my parameters. I want to do most of the point set, but I want to make sure I'm incorporating a lot of ideas from sort of shape of space type things. I want them to be able to play around with manifolds a little bit too, which is hard to get, which you can't really get to straight from point set. So I'm trying to do some sort of, to do the point set formally and incorporate that with some of the surface and stuff. And at the same time, I'm trying to do something that doesn't step too much on real analysis and is accessible to our large number of teachers that we're going to have on the course.
That goes through the different types of proofs so that the other teachers who get the students coming out of this will be able to say, remember, this is a proof by contradiction. What are the types of things you need to do? Make sure you start this right, or have you considered. Some of them would be directed like that, you know, so that they would understand what the different proof types, in essence, are when they've come out. So that's, I want them to be able to do that, but I want them to understand some of the vocabulary of proofs in general.
When I think about teaching a statistics class, that's all I think about. And I don't want students to just memorize formulas. I want them to understand why they work.
Was this an introductory class, or was it? It was
whatever was required for math majors.
Oh, so it was a math major.
It was in the statistics department.
Did you use calculus?
Yes.
But what about the stat classes you're going to be teaching?
Yeah.
I don't think they're calculus. I mean, I think they're very
introductory stuff.
Yeah.
That's what you teach.
Yeah, and so, but I think that's the way that the courses have been structured. I think all the guidelines for statistical education is set to go far away from that as possible.
Have you heard of GAISE?
Yes.
GAISE. GAISE guide.
It's guidelines for instruction in statistical education that
they say don't do what you had.
Exactly. And the great thing with the technology, the way it is now, in fact, a lot of the meetings now, the statistical meetings are focused on methods that are randomization methods, bootstrapping, rather than using, not even, at some point doing away completely with the normal distribution, chi-square distribution. All the stuff will be thrown out.
We do, I do enough non-parametric stuff to sort of look to the future a little bit.
But your class, you have to do that if you're going to prepare for actuarial science.
So can you talk a little bit about the types of activities you've got in your class?
Well, there's the great news is, like every statistics conference I go to, you get activities galore. Everybody's developing really great ones. I taught Cal Poly in San Luis Obispo, and they have a lot of great educators there. Roxy Peck in particular has done statistical investigations. Right,
Yeah.
In fact, Beth was my mentor, and they're developing just amazing things, and so it's you don't have to invent anything. People have already developed all these activities to use in the class to really develop conceptual understanding, which is really what we want.
Away from sciences in general, because I like the closed laboratory of my mind rather than working with chemicals or working with the physical lab. So statistics is messy and data and numbers, and I didn't want to handle any of that.
and showing them how to use all the senses and collecting data, like even listening. Like there's Roxy has one that I use almost every semester, which is listening popcorn popping. How long does it take kernels to pop? And it's great because it forces them to actually sit there for 5 minutes and listen, and record data from listening. And you don't think about that.
I think it's great when there are these courses available where you really can avoid problems with algebra and this sort of thing, and introduce you to all sorts of interesting thinking. But there are situations where you don't have the luxury of this sort of thing. Maybe you have students where they have to take whatever it is, whether it's college algebra or pre-calculus or whatever that course is that they have to take to fulfill that general requirement. And I guess something that I like to do is sort of in the same realm as sort of giving them stuff that they don't recognize as mathematics, is just shocking their system in some way. The first day of class, you do not do what they're expecting you to do, even if it's you are studying.
Talking about axioms within the integers and doing some number theory and things like that. So there's sort of a little bit of narrative, and then maybe an activity, and some more narrative. And then one of the other things we do is we really think it's important for students to learn how to read proofs, because they are going to have to use resources eventually. So we may kind of work through the ideas behind, like, say, the proof for division algorithm in a very inquiry-based way, having them do activities that get at the idea behind the proof. But then we'll have a section that says putting it all together, and we'll have like a written-out proof with some blanks left open and some little circled question marks where they have to add in missing details and provide explanations.
Then they will go home and they'll write up a portfolio, and they write up a final version of each example, and they put that together in a portfolio, and they turn that into me. I would ask them after a couple of weeks to turn in their portfolio on Monday, and they'll look at it and make sure they're doing it. And then I say, I want you to continue doing this, and you can give it to me as often as you want, and I will check and give you feedback. And you just have to have it completed. Actually, have to complete it by midterm, and then by the end of the semester. But that's required.
And so what we're doing now is that is a different operation. So we do addition, and then with all the different things, so with integers, and then with fractions and decimals. So and then we do because what happened is we would do addition in all the different ways of doing it, and then multiplication, and then division, and then in the last 2 weeks we would cramp in fractions. And that wouldn't work, because you can't drop that, because that's the part that they need the most. Then again, you can't. Then we tried putting fractions in the front. Well, that didn't work.
You can't
because
do
they
it
didn't
for
know the
division,
models.
right? You can't, and you can't.
Right. So now we're trying to somehow make it stranded by operations. I don't know yet if that's the best way, but it might be nice to be in communication with you about that, because we're playing.
I like the idea. That certainly seems like they come out thinking of the type of number as those are the ones that are vaguely coherent. They come out of elementary school and see what you think. Oh, I understand. Integers you do this, fractions you do this, right? So if in this experience you sort of organize them orthogonally, because they do remember from elementary school, right?
Yeah, and they don't addition doesn't sound threatening. Well, if I can add numbers, why can't I add fractions and somehow
and rational?
It's like what's the problem? And you can even maybe once in a while mention a real number, maybe something's not a fraction. Like it's just like this way you get a chance to even think about that, which you never do if you go the other way because you never even get to the point.
Right.
Another way could be to let them talk to their neighbor about the proof.
Yeah, that's a good thing.
In case it's very quiet. And then you can say, oh, be prepared, I'm going to call on one of the groups to share. And then, of course, you'll pick the ones that you feel like you need to hear from.
Anyway, in spite of that fact, and then express your own doubts.
If it was up to me, I would just do it.
I just think that if you followed that same line of reasoning that you did here, I would get this conclusion, which is obviously false. And at least make them skeptical as to whether it's even true to begin with.
Or prove them finding our example kind of
They have
statements.
a prove or disprove.
Right,
And then you make statements. So then they don't know.
Right, and it's interesting to see them try both things and decide what.
That makes it much harder for me.
It does.
You have to decide.
Yeah.
You just have to decide.
It takes more time.
Yeah.
Yeah.
Let me just say one more quick thing, which in response to Stan's thing, because I think there's a principle there. I think the reason I thought Stan's idea is great, and I will do it next year, is because more people are participating in that moment than if you just point to one person. If you say,
people are trying to think, and one thing I don't like about calling on people is that, like, I just remember being a student and having some teacher say, well, what do you think? And me just being like,
well, except for
wheels or something. And I mean, that's the last thing you want to say to your teacher who, like, thinks is forming an opinion of you. Isn't it? I don't know. Like, so I really do not like to just randomly call on someone if I got avoidance. Like, I would prefer to get volunteers first. And if there are no volunteers who are really quiet, then I use some other way.
As they're talking, you listen to a few people say, oh, that's interesting. Oh, that's interesting. Oh, you should share that.
I've done that too.
Then you're picking people
I had a
grad student through a less.
A couple years ago, she mentioned me. She came to me about 5 years ago, and she was in one of my grad classes, and I cold called her all the time. And she came to me almost in tears after the second day of class. She was terrified of being called in the class. She was the only woman in the class, and she felt like they was put her on the spot. It was really unfair, and I agreed not to do it. And I just kind of got out of cold call. But I think the point of just having 3 or 4 students who say everything, that's a bad situation to be in.
It's unfortunate it didn't make progress from that. It was my real problem in class. The very first day, the professor gets up to the podium and starts to talk, and the door bursts open, and 2 guys come in with a long rifle and shoot these blanks off, wake the hell out of the class. They throw a stuffed fox into, toy fox into the room, and then some guy with a big straw hat gets up on the other side of the room, comes over, and they start yelling at each other. Okay, then they all leave. Now, the situation was the hunter shot the fox on the farmer's land. Who did the fox belong to? The hunters are the farmer. And, everybody has an idea. They don't have a clue what the law might be, but they have an idea of what in fairness that ought to be. And so my idea is you start off in class, you give hypotheticals and ask the class to discuss what would be fair. What should the result be? And that's just one example how you start. Then what you do, when you're done, you give those students an assignment after that. They're never to read anything beforehand, but an assignment of some cases in which that issue was discussed. Okay? Now your next day class period is you give them a new hypothetical, and you debate about this, and then you stop and debate. Then you talk about what they read the night before, and you compare what they read to what the judges said, or what they said in class versus what the judges said, and see how that compares. And to the extent, and sometimes they can be right, the judges can be wrong. That happens all the time. But that's my idea how it should be taught.
What if you're in something like teaching handwriting? Now, why would a math teacher teach handwriting? Well, it could be because you have students who can't write. Right? Now, how are you going to teach handwriting in inquiry-based learning? One approach is to send people out. The other thing is, some people think inquiry-based learning is to go out and inquire yourself. It's almost like getting a I don't think that's what inquiry-based learning is. But the question is, what would you do? You've got a math student, you're in a math class, you have pretty good knowledge on math, because you can give him calculus in this test. That's pretty good. Give him, say, all right, write up the explanation of this problem. Answer the questions in English, what answer results mean, something like that. And they hand you a piece of trash. I mean, it's badly written. English makes no sense, and so forth. So, all right, how do you handle that with inquiry-based learning?
I'm John Osnak. I'm at the University of Dallas, which of course is in Irving, Texas. Not to be confused with the University of Texas at Dallas, which is of course in Richardson. I've been at the University of Dallas for 3 years. I consider myself to be in the lap of luxury because everyone in the department is committed to teaching IBL courses. We have 2 courses which departmentally have been dedicated as more method courses. A general survey or general liberal arts course we call Euclidean and non-Euclidean geometry, which is really nothing more than an IBL course in logic with geometry as the metaphor for the excuse to do it. And then we have a course we call linear point set theory, which is our purely hardcore, more method, here are the definitions. It's almost a pre-topology course, go forth and prove. And so I have taught several courses like this. I have the arrogance to have already taken what other people have done and said, that won't work for me, I'm going to change it already. So I'm here to stoke my own ego to see if I'm doing it right or wrong.
My contention is that you can teach calculus with a good notation, and the students get, and if it's IBL and they get up and they get to talk, that they're not going to be hindered by in their physics classes and engineering classes. I mean, you can tell them about the other, but only after they have a good grasp. They're not going to be hindered by it. In fact, I have another role as a consultant. I've been an industrial and government consultant practically since the 50s, and I get to see what happens to physicists and such, and especially like chain rules in multivariable calculus. They just died. People died because of bad things, and the physicists are very smart. But people have their limits with those chain rules. And this is a function of this. This is a function of this. Total derivatives, partial derivatives. They just die because they can't. They're so on such shaky ground. And I think it's a serious matter. Problems in science and industry and government. These are hard problems. And somebody hindered with a poor notation is at a terrific disadvantage. I'll put it this way: somebody they'll have two functions with the same name. Function, frequency, energy. You ask them what f of 2 is, they have to say 2 what? That's a complicated mathematical system. If you have something you're calling a function, and say with domain the whole numbers, and you ask them what f of 2 is, and they have to say 2 what? 2 units of what? This is just hopelessly complicated. Well, now
What do you guys think the challenges of this kind of thing in the world where now there's like, you can look up all sorts of problems on the internet, and find solutions and write to like the problem solver guy. Like, how does that fit in to this whole, like I can very easily picture my students like all getting together, like and searching on the internet and emailing the guy who answers all the hard math questions.
Well,
and then,
they'd
still have to come to class and explain and understand, of course. But like, is that a different context than what it was?
No,
like, how do you deal with it?
If somebody copied a proof out of the book, or now these days off the internet, and they try to pass it off in class, it's like a $3 bill. It just doesn't. It comes across just total fake. They just speak like a textbook, and if you get them off just a little bit from the subject, they're just exposed. They just can't take it. If you have a class with a really high standard of proof,
And the high standard, if I'm writing up a paper, and I really want to write up something, a research paper, really carefully, I ask, would this pass muster in my junior level analysis class? And if it doesn't, I go back and make it more careful. I don't use any language in my papers that I wouldn't, that's more sloppy than what I use, what I allow in my class. But it's really, if they're copying it, it just comes across fake.
Well, I agree with that. I agree that you would be able to figure out that it's fake. But what if they don't copy exactly? Like, what if they find it, they read it, they understand it, they spend some time? Like, that's a little bit different than going off on. It's very different than going off on your own and solving the problem.
And I sometimes wonder if maybe we don't try to avoid that to the degree that then the students say, well, I'm going to be the only one that made a mistake here. And maybe almost making a joke out of the thing and making some intentional mistakes yourself takes off some of that pressure.
This is something I'm besides mathematician, I'm an improv comedian. So this is something I do on the first day of class. I call it the circus bow. So the idea is we all stand up like this, say, I failed, and take a giant bow. And so I try to do that and, make some silly mistakes. And then, all my students, I make them stand up and I'll do this. And so it's making a joke out of failing, because I want them to fail, right? And it's okay, and it's funny, and it can be funny. So
maybe it could be that we could include tasks where you say, what were the things that you tried that didn't work out for this problem, and then have a list of things.
Yeah.
You say, I tried this and it didn't work. And that way, it's actually honoring the fact that, but somehow that helped us. So maybe that's a kind of activity that we need to incorporate intentionally.
Mm-hmm. Oh, I do it all the time. I do it all the time. And that is they go to the board and they get it wrong. And then that is a great source, and we talk about it and we see what's wrong and we do it, and it's great. We celebrate it. And by the way, this is 5 elements. Element number two, fail, make mistakes. I mean, the whole point is, one of the basic things I think we should be teaching people is not to feel like, oh, I got to feel bad when I make a mistake, but to realize the positive value in a mistake. It's directive. It's saying, okay, from that I learned that this was exactly the problem, and that directs me to the right area. So it's not to be avoided. I think it's just wrong to tell people, boy, the perfect life is one where there's no mistakes.
Right. And you have a great quote.
These boards and publicly share them with the rest of the class about mathy things that were related to the themes from class. And they could theme them however they wanted. So if they happened to be reading 17 magazine, they could bring in something computational or quantitative statistic there, something that seemed related to them. Right. And it seemed like a really cool idea that sort of didn't seem like forcing it. It really seemed like a natural way for them to look for things that related to math that they found interesting.
And that's good for when they're teaching, because that's how they're going to engage the kids. They need to connect that, right?
Yeah. And so with the free service teachers, it's always meta. It's got to be something where they can imagine how they would use this with their own students.
Well, it has to be organic enough to keep to not look fake to their students.
Right. Or even harder.
That they are. On strategy that I found helpful in the content courses, when I really get stuck in a completely situation I can't figure out, I completely step out and I say to my students, okay, now so imagine you were me. Because you will be me at some point. So imagine you were me and your class would do whatever they have done. What would the teacher do? So that way they help me out. But they also really think about something that's important, because they will end up in the situations like that. But it helps me because I don't actually have to make the choice by myself. Because I am in the room with 30 other people that will be teachers. So
I didn't go to any workshop. I had a vague idea what it was. So you said, what are your goals? So I sort of made like 2 or 3 axles. And then I decided, well, okay, I'm smart. How can I do this, right? So I just kind of wung it.
Is that past?
I don't know.
For instance, you think you ought to establish the number system from the integers before through the calculus. And they're my dearest friends and great colleagues in all kinds of battles, and I just can't see it. I'm just not going to do it. And not going to develop. And he said, Morse does everything axiomatic from a set of axioms. It's like, you'll see that with not calculus. You don't use it.
I did it that way. At Chicago, I was an ideal calculus course based on Spivak's book that started with defining the integers, then building the rationals, then doing Dedekind cuts.
I've never had the nerve, and I've always suspected Chicago is a very selective bunch of people. And in Texas, where I had it, kids wandering the ranch. I was valedictorian in a class of 7 when I came in. These days, you need to be in the top 10%. To get in here. The question is if you were the first out of 7, were you in the top 10%? I've never figured that out.
You know, one of the things I think with limit, I remember back when I was taking high school geometry, the measurements of the inscribed angle being half the intercept. To me, it was obvious that when you would swing this chord on out like this, that when you became a millionth of an inch away over there, you still technically had 2 secants. But going an extra millionth of an inch wasn't going to change the fact that that intersected arc was equal to twice the angle. And so that wouldn't have been acceptable as a geometric proof because the whole idea of continuity wasn't acceptable. And yet I think if you go back to Archimedes, they were using this idea all the time, that was how their logic went. And I think we do ourselves an enormous disfavor. If earlier in geometry we had used the idea of limit, well, what do you think is going to happen if you swing this thing an extra millionth of an inch? What do you think is going to happen to that angle there? Students could get a very strong intuitive idea of the limit was without ever having known that epsilon delta and all this stuff was. They could still understand it perfectly well.
Well, it comes out that there's a lot of easy ways to do it, but the kids pick up very quickly. You don't tell them what to do, but I'll give you an example. The very first day of class, I'll ask the following question. First, I'll go through the roll and ask them so I can identify them, because I don't like to say you there. I would like to tell them Mr. Smith, Mr. Jones. The very first day of class, I came over and said, everybody knows about airplanes, and they say, I said, when an airplane takes off, is there a last moment on the ground or a first moment in the air? And then we'll start talking about something. I won't mention it again. And about 2 weeks later, someone will say, remember that airplane? What airplane? And then they'll make some comments, and I'll say, well, that's kind of interesting. And then someone else will make a comment. Now, invariably, they're all wrong, but I don't say anything. So that's kind of interesting. But what about these other questions that we have? You can say, how do I say continuity? How would you handle that if you don't have this LIM and all this other? Well, I would encourage you to go in that where the refreshment room is, the Oaks, and there's Creative Mathematics by H.S. Wall. You should put your name on there and get a copy of it. The reason I tell you that is I'm going to draw a picture for you. Suppose he uses, instead of function, the word simple graph, and that's just or graph is just a point collection. We're talking about the plane, so just a point is an ordered number pair. First thing you could ask is, what's a point? They'll say it's a dot, it's a place, they'll think about it. And then you say, how about an ordered number pair, like the first number to the second? And then you ask, could you draw a picture? All you will draw this vertical line or horizontal line. And I think most of you know there's other ways of doing this besides that. They don't see it. You go on. Anyways, you know what a graph is and what a simple graph is, and this is all involved. And then continuity. This, I think, is particularly cool with geometry. If you had a function and it had a point in it, what does it mean it has, I don't use continuity, as properties see it there. That's really easy. If someone draws 2 horizontal lines, now they know what that is because you talk about it. Then you can find 2 vertical lines, 2 horizontal lines at that point. And you can find 2 vertical lines at that point. So every point of this function graph, that's between the horizontal lines. Between the vertical lines, between the horizontal. It's a very geometric. They can draw those pictures without trying. That's really what you mean by that. You don't have to talk about this LIN and all this, and then you can ask them. This is an interesting question that always gets the wrong answer. If you had a simple graph that has exactly 2 points, is it continuous? And they'll say no. And you don't say a thing. Finally, some clever kid in the class will come back and say, well, yes, and the others are all blue around us. But it is. Because they kind of think it has to look like now you've got them curious because they don't think that this building was continuous. They can do a lot of things. If you add 2 functions, each has property ceilings on them, the sum does, the product does.
Well, but he didn't mention it like that.
I've never seen this Then after that, see, they get that down. You still don't tell them that it's continuity, at least I don't. Then you can say, well, it has property C at every point, but it's on an interval, so then it has property C at every point.
My first obligation is to make sure they know by teaching efficiency, which is what they're going to teach. Well, I mean, if they're going to teach it, where are they going to learn it? It's not for me.
To me, and then I have to redirect them to the class every time instead of just directing them to the class. So I think the next time I probably won't do that.
I think that's a good observation. The grading doesn't have to be that coercive. That if you get the spirit of the class, we're trying to solve these problems, we're trying to figure this out, and we're all working on it together, and build up that spirit of it. And then they do it, and when they're successful doing it, they take great pride and satisfaction in that, and that drives what happens. And you can remind them that yes, you do have to present. There are some who like to just sit there and absorb it and be able to do well on a test, and so you go on. No, you have to also present. But I don't think you really have to give points to it as you go along.
My initial instinct for doing it was because I knew this was going to be so different. I felt like the more structure I put on it, the more likely they were, potentially the more likely they were to buy in. And if I was kind of wishy-washy, oh, it's 10% of your grade, don't worry about it, it's 10% of your grade, I'll figure it out. I think I would have got, maybe I wouldn't, but I think I would have got questions throughout. How are you going to talk about it? Because they're so grade driven, that getting them out of that kind of mentality is tough.
But my students are very grade driven too. I mean, I teach at a highly selective liberal arts college, and part of it is that, I don't know, I mean, it was 10% of their grade. I think it has to be higher than that. Part of it is that even if you're not grading their presentations, right, actually there has to be a large enough portion of the grade that they're going to take a serious hit if they don't take seriously the fact that this is part of the, I mean, because actually if it were 10% of my classes, that I have a certain percentage of students that say, I'm happy with the B, just won't worry about it.
Yeah.
You know, so not, you know, I have also some that would definitely not be happy with the B, but I have enough that would say, you know, I'll just sit here and watch and I'll do fine on the tests, which of course they won't, but that's another story. So it does have to be a chunk of the grade or they won't take it seriously.
We're going to go with the wrong way. So we have one geometry. Now, if we could have a second semester of geometry, I would like to do this given that our students will have only one semester of geometry, and particularly a lot of them will be teachers. I will say that the first obligation is to
And then he talks about marginal profit. He talks about marginal profit and marginal cost and all this other stuff. And I'm sitting here just, hey, you're using calculus all the time. Didn't you realize that this was related to calculus? And what had happened is when this person had taken calculus, they memorize that when you take the derivative, you take the exponent times the coefficient, you go down power, but they saw no connection between this of comparing rates of change.
And I would say, you know, so it still gets assessed.
These people have had calculus.
And they've had calculus and basically dropped out of it. They got like a C- or something like that. Maybe they're planning to go there. They forgot those plans. They went on to become a business major. And they did all the stuff and looked at where they crossed and they didn't do enough of that stuff. They usually got a business major. But for them, calculus is still something they never understood. And here they are. They're using it all the time because they're doing marginal costs and all this other stuff. They're using it all the time. They don't even know it's calculus.
But they're using it in a context that means something to them.
Oh, yeah.
And of course, we'd like the calculus. What do you guys think? What do you think of this discussion?
Well, I think it's definitely a good goal to break down calculus into this set of problems that they can, like you were saying, work through. I think that certain rotation-wise things we need to put on the back burner for our initial discussion.
Now you put what gets on the back burner?
Well, I don't know. You came in and kind of just said differential, dx. I understand that that's going to come up, but I don't know. Like when I think about it, I try to think about those sequential problems, and I always get stuck with even the first two. Like, where do you start? So I don't know. That's kind of my question. Is what's a good first question?
Application of it, they would be able to understand that much more readily on their own, simply because they deeply engage the basic idea, going through an exhaustive list of all the different things. So right there, you're saving time.
Well, the reason being because they don't. How do you decide what's supposed to be covered in a semester? Is that something that's decided by the department as a whole, or does each instructor do it? And if the department decides it, how does the department decide? Then it becomes really
The department decides for us. I mean, we're pretty much given. There might be there's a committee, and they decide what material must be covered, and maybe one or two optional sections, but you're expected to cover that so that when you go to the next course, then they're picking up the next section, and that way there's not a gap.
Because it would be expected that not all your students would.
Right. We teach 80 sections a term, most of it calculus, and so who knows who the next term you may have.
I can't see everybody's name tag. I'm just curious where people, like what kind of schools people are at. So.
I'm imagining Gettysburg is a different phenomenon. Probably much smaller number of sections.
Suppose the department said we would like a student to be full pick whatever it is. Whenever you're thinking of a program, we supply it comes out that's sort of
Are we thinking about trying to bring the calculus and teaching pretty much like any IBL we're trying to bring?
I would say there's not much debate on that. I don't think that it's really very controversial. What few sections might be a little controversial.
Do you think that what they're suggesting might cover is reasonable?
The vast majority of our students are engineering majors, and so are engineering majors. But we are in the College of Engineering and Science, so it's not us them, we are them, right? We spent some years ago a lot of time looking at what to put in, what to take out, lots of conversations. So I think pretty much we feel okay with that.
Is everybody here comfortable with what your department is saying you should tell me?
My department's evaluating calculus this year, and our calculus, well, the whole department is going through a review or whatever, but we're evaluating sort of how we're doing things. But the way we've been doing things is sort of, we have these labs attached to the calculus class, so it's important for, even if different people are teaching these classes, to be at the same pace, because the students all take the same labs.
When you say the same pace, on any particular day, everybody is talking about it.
Every couple of weeks there's a lab, and everybody has, all the students have to for the lab, and
what is a lab?
A lab, it really is just like an extra problem session. We have an assistant instructor that leads that, and he writes these problems and has them work together, which is what I would do. I do that anyway in class, but yeah, there's a weird sort of sense that that we're supposed to lecture and someone else is supposed to give them the problem sessions. I'm not entirely supportive of that because that's what I would like to do.
So is it because the lectures are in like gymnasiums and the labs are in small
No, I
rooms?
mean the lectures are about like 35 people each, and then but the labs are like 10 each, so there's a little bit more focus.
I am learning skills counselor for the math department, and I work with in-service and pre-service teachers, the in-service teachers in K-12, and currently our IBL courses they were differential equations and linear algebra were together. Now they're separating, so I'm just here just to learn about linear algebra.
I'm Jane Cushman. I'm at Buffalo State College. I'm a math educator, but I also teach math classes, which is one reason why I joined Buffalo State College. I do the modified Moore method with most of my methods classes in my secondary education major, and my geometry class I've been doing with IBL.
They didn't organize this. Yeah. Okay. But that's the type of thing you're talking about.
By the way, this algorithm goes back to Banach, Canaster, Steinhaus, and its beautiful property is it guarantees you at least 1/n of your fair share. So if it's being divided about, each person walks away, unless they have exactly tied preferences, each person walks away with more than 1/n of their perceived share.
Lee, anything to add to this? We're going to run out of time. What do you say?
All I'll say is that at my university, liberal arts mathematics and the required course intersect in that all of our students are required to take one math course before they graduate. And the way we handle it is we have a course entitled Liberal Arts Mathematics, and we can put after the colon whatever we want. So some people do environmental mathematics, some people do music and mathematics. I choose to do statistics through baseball. We can use numbers in any way we want. We can get into all kinds of interesting discussions. And we are sneaking up on them because they're learning some manipulative skills and some mathematics. But if they're not careful, they actually have some fun.
If they're not careful.
Yeah, that's the way we do it.